Hello, my name is Stanley Trent, SMI President. Welcome to SMI and the SMI Training video. This might be a typical SMI surveying package that you would receive. The 1 meg RAM card, a video, soft environmental case, cable to instrument, tripod mount, cable to PC with adapter, PC Enter, a program for Construction 5 control files, an SMI transfer, card manual and overlay, and the 48GX. The SMI Surveying Package. This is a new tripod mount that swivels. This program contains all of the SMI surveying software. These are unique features of the basic coordinate geometry, standard coordinate geometry, the advanced coordinate geometry contains all of SMI COGO. Data collection contains all of SMI COGO plus the ability to work with these instruments and raw data. SMI's Construction 5 contains all of SMI software, including SMI's powerful construction stakeout programs. We're now installing an SMI surveying card. And a 1 megabyte RAM card. This is optional. And now let's install the overlay. Put the 3 tabs in on the left and press in on the tabs on the right, causing the center to bow up slightly. To remove the overlay, cause the center also to bow up slightly. Let's try installing one more time. Notice the center bowing up slightly as we install it. When we press on, we see this. If we would like to clear the memory of the 48, to start at square one, press on A and F. It says try to recover memory. We press no. And it says memory clear. Alpha K enter. This assigns the keyboard. It also tells us the version number and the card name. This is the version number. This is the hourglass, which indicates the program is still running. it takes about 30 seconds on the GX and 1 minute on the SX for the keyboard to be assigned. It's finished when you see this. We have the home directory, Kogo directory, and the job directory. Just like a PC, it has directories. This is the name of the job, current job. User should normally be on. This is the mode, in this case, setup. The reason for the 0 is we're not occupying, or we're not backsiding a point, but the 1 means we're occupying point 1 and we've just stored point 1. The NN stands for next number, and in this case it's 61. When we want to access a soft key function, we press the soft key. Like occupy is the soft key function, B is the soft key. In this case, C and D is inactive. Note, access it. SDA stands for separate distance and angle, and we'd press F to access that. Job has a box around it. That means when we press job, it will give us a series of soft keys. In this case, old, new, and we have the option of changing the north, east, and elevation values, or the note even. Notice job has a box around it, random points has a box, but point inverse, no box. That means they're direct access keys if there's no box. We will first show you how to create a new job by pressing Job, New, keying in the job name, in this case Sample, SMPL, and press Enter. It's now saving job 1 to the memory card. To back it up, we're going to start at point 1. We're occupying point 1 automatically when we create the job. We're going to traverse north 15 east for 200 feet. So we key in. First we press traverse, and then key in 15, press azimuth, key in 200, press horizontal distance, and it moves up to point 2 and stores it at point 2. So we're occupying point 2 is stored, the next number is 3, there's the direction and distance we've traveled. Now we'll travel north 8750-30 east, 87.50-30. If we press bearing, it will prompt for quadrant. We key in a quadrant, press Enter. Now we'll travel 180 horizontal distance, and it stores point 3, which is here. There's the direction and the distance. We would like to repeat that at point 4. So we press the next key and we see repeat on the soft key. So we press the E key to repeat. And now we're at point 4. We move now over to point 5. By pressing repeat again. Now we're at point 5, which is here. We're ready to traverse south 1820 east for 200 feet. Now, one approach to do this, we can key in the quadrant first if we wish. Quadrant 2 for southeast, 18.20, and press bearing. Hey, where's the bearing? We have to press next and we'll find it. Bearing. And notice it converts that to angle right, azimuth, and bearing, south 1820 east. And now we key in the horizontal distance of 200 feet and press horizontal distance, and it moves us down to point 6. And it tells us we're on 6. There's the bearing and the distance. We traverse south 7040 west, 70.40, and this time we're going to press bearing without giving it the quadrant first. It prompts for a quadrant, which is 3. We press enter for a distance of 110 feet. 110 horizontal distance. And now we are at point 7, which is the PC of the curve. So we press the curve key, and that gives us, it says arc definition curves, delta, radius, tangent, length, chord, external. Then we have other options here, degree of curve, and other options here. This is in the cases where these points are already stored. In this case, they're not stored. So we press curve and give it the information that we have. In this case, we have a radius of 513.83, 513.83, and press radius. And we want to travel along the arc 100 feet, and we key in 100 and press L, and it says left or right. It also gives all the missing curve information, and we are moving to the right with this curve, so we press right, and it also gives us an opportunity to store. When we press store, it's going to store the radius point or curve center, and also this point 9, which is on the tangent or on the curve. So we press store, and you see what it's doing, storing points 8 and 9, and it actually gives us the coordinates for point 9. Now we need to traverse for this distance on around the curve. We could repeat, but that would repeat the 100-foot distance. We need to give it a new L of 116.73. So we key in 116.73 and press L. And it stores point 10. Now we press traverse. And we know in this case that we have north 8410 west for this distance and this distance. In some cases, we may not know what the forward tangent is. It actually computes the forward tangent when it runs through the curve. Let's look at that. When we press shift right and azimuth, it gives the last azimuth, which is really also a forward tangent, 274.5001. Now let's check and see what the bearing of that is. We'll press shift right, azimuth to bearing, and it's north 8509.59 west. Hey, this is 8410. We must have made a mistake somewhere, because that's 85 and this is 84. Let's check and see where that mistake might be. Let's check the bearing from 6 to 7. 6 space 7 point to point. South 7040 west. There's our mistake. It should have been 7140 west. So let's show you how to correct an error. We correct the error by moving back to point 6 and starting again. Now there's another way. Let's suppose there's 100 points here that we'd put in incorrectly. Then we could use transformation just to rotate all these points forward by 1 degree. But in this case, we'll show you how to back up to this point, point 6, by keying in 6, shift right, occupy, and we want to traverse now correctly to 7. When we press traverse, it gives next number 11, but we want it to be at 7. So we key in 7, shift right, enter, which is next number over the enter key. Next number is 7. Now when we press traverse, we're at 6, the next number is 7. The last point was 10, but we're not concerned about that. We're going to override that later. So, south 7140 west, 371.40, and we press bearing. This time we're right. You could tell a few minutes ago we were wrong. I was so busy worrying about the videotape, I didn't even notice the mistake. So we'll go 110 feet, 110 horizontal distance. It says 0.7 used, override. Yes, we do want to override that because it's incorrect. So we press enter. Now we're at the curve again. We press curve. Give it the radius, 513.83, 513.83. Press radius, length, 100, L. And we're going to the right, and we want to store. 0.8 used, yes, but we'll overwrite that by pressing enter. 0.9 is used, we overwrite that by pressing enter, and it stores 0.9. Then we give it 116.73 and press L, and it traverses to 0.10. That's used also. We'll press enter to override it. Now we press traverse and press shift right, azimuth to pull the last azimuth or forward tangent out. Now we press shift right azimuth to bearing to see if we're close now. 840959. So let's press on to clear that, and we'll go back, shift right and azimuth, and we're going to subtract 1 second off of that and use it. 0.0001 minus, use that as our forward azimuth, and our distance is 117.78. Horizontal distance, 0.11 is stored, and we'll use the same direction by going shift right, azimuth, for the distance of 220. Oh, whoop, I entered too much here. Let's back off that and press azimuth to use it. 220 distance, and now that we've traversed to 12, we will inverse to 12 from 12 to 1. 12 space 1, point to point, and there's our distance error, which is fairly good. Now let's check the area. We'll use random points to check the area. If there's already something on there, just press on. That'll clear it. Now we'll traverse. We'll go from 1 to 2 to 5 to 6. So 1 space 2 space 5 space 6 space. Now we're at a curve. Shift right and minus, and 7 space 8 space 10, which is down here at the PT. Then cursor right, the R key, then space, and we go to 12 space 1, enter. Then we press RPTR. RPTR, there. It traverses around the boundary and gives acreage, square feet, and perimeter. If we hadn't made a mistake, we could have just pressed view area, but when we made the mistake back here at 6 and we restarted by occupying this point, it automatically zeroed the acreage. So here you see the acres, square feet, perimeter, and precision. The area of lot 1. 1, 2, 3, 11, 1. Random points. 1.3 space 11 space 1 space 1. We'll force close it by giving it 1 twice. Press enter, and we'll see RPTR on the soft key. We press that, and it automatically is traversing around this boundary, giving us the information. We can press space. Whoop, we didn't press it soon enough. Let's do it again. Random point traverse. It traverses around the boundary. Let's press space and it'll stop. See, it says paused, and it gives us the bearing distance from 2 to 3. We press space again and it starts. Press space again and it pauses. Bearing distance from 3 to 11. Space, and we can stop it and get that information. So our acreage here is 0.9567. 0.9567 acres. Now let's get the acreage around this area here. Lot 2. Random points. 11. Oh, notice we have information on there. So what we're going to do is press on. Then we start at 11. Space. 3 space 4 space. And we're at a curve. So we go shift right minus 9 space 8 space 10. 9, 8 is the curve center or radius point, and 10 is the PT. Cursor right, space. We go back to 11 and force close on 11 by giving 11 twice at the end. That's important. And we press random point traverse to get that area. There's the curve and the area, 1.1197. Okay, now we want to get this last area, random points, on to clear.
Well, yeah, I'm doing that, but it's a separate thing. They don't match
9 space 4 space 5 space 6 space shift right minus 7 space 8 space 9 cursor right space 9 again, enter, random point traverse, and we're traversing to get that area. And it's traversing around to get the area, which is 0.9947 acres. Would you like to see what it looks like? Press S plot for screen plot. And there it is. The reason it drew it in the corner here is because there's a radius point up there that's being used that was a part of the drawing. We press on to get out of that, and so now we have figured the area around the boundary, the area of each individual lot, and the bearing distance across these two. And let's now assume that we'd like to do a predetermined area so that we change this to 1 acre. We want to change this to 1.00 acres. We want to get rid of this. We want to find out how far we need to go along this and along this to get it. So we have 9, press on when something's on the display that you don't want. We want to go 0.9, 5, 6, 7, enter, 1 minus. So we want to add 0.0433 acres to this line just to slide it on over. So we press shift right, pre-area. We want to do the slide method. 0.1 is really 11 here, so we can 11.1. And a direction, a point on line is 10. Point on line 1. Then 3 is 0.2. And 4 is point on line 2. And we want to now give it either the acres or square feet we want. In this case, we'll give it 0.0433 acres. And we need to go distance 1. We need to move it 8.45. From 0.3, it's 8.485. So all we really need to do is store points 3 and 4. And we'll store that at 13. We'll store 0.3. And 14 we'll store 0.4. Now I believe 13 will be up here. 3 space 13 point to point. No, this would be 13 and this 14. Let's see if that's right. 3 space 14 point to point. 8 feet, yeah. So now we have a new boundary, 1, 2, 14, 13, and 11. Let's check it just to see if it's right. We press random points on 1 space 2 space 14 space 13 space 1 space 1, enter, random point traverse. And it should come out with 1 acre. We'll see if we did it right. .0000 acres. That's close enough. Now let's do a hinge method from this side and show you how that works. We press random points, and we go on, and we start at 9, and that's in a curve. Shift right minus 9 space 8 space 7, cursor right space 6 space 5 space 4. So we're starting at this point and going to here to figure the area. We press enter, and let's see if we can press next and find predetermined area. Hinge method right there. Press hinge, enter desired area in acres and our square feet. So we'll enter 1 acre exactly and press acres. It's calculating, and it's going to create a point out here, a distance of 181.90 feet from 5. And we can store point, and let's just press store point and see where it puts it. Puts it in the next number, which is point 15. So now let's check it. Random points, on, to clear, 15, space, 5, space, 6, space, shift right minus, 7, space, 8, space, 9, cursor right, space, 15, space, 15, enter, and random point traverse. And it's computing the area, and it should be 1.00 acres. And look at that. Would you believe, to the nearest 10,000th, it's 1 acre. We will create a job and store these points beginning at a point on the tangent, going to the PC of the curve, storing the curve center, PT, PC, curve center, PT, and a point on the tangent. Once these point numbers are stored in the 48, then we enter the control file as horizontal control. We will now show you how to do this. On key. We now press Job and New, and we key in the name HWY, '81, and we press Enter. And we see the display, Highway 81. We're occupying point 1. In this case, the 5 indicates that we have chosen an instrument. We want to take that off, change that to manual entry. We have elevation zone here. We'll take that off. We press Next, Next, Instrument, and Man 1 to go back to Manual 1 entry, and the 5 has disappeared. To get the 3 off, we press Change. And we turn elevation off. We see it's on here because there's a box after elevation. So we press the soft key C under elevation, and it says won't store elevations. We press Setup, and we see now. And now we see no flags up here. There's no 5, indicating that we have chosen an instrument. There's no 4, meaning that notes are on. No 3, meaning that elevations, notes, instrument, all turned off, along with raw data. Now we're ready to press Traverse. We're now ready to traverse from 1 to 2. We're occupying 1, and we're traversing North 42 East for 500 feet to go to point 2. Press Traverse and key in 42 degrees. Press Azimuth for 500 feet and press Horizontal Distance, and it stores point 2. We're at the PC of a curve where we want to store the radius point or curve center and the PT. We'll show you now how to do this. We press Curve, key in the radius, which is 500 feet, 500, radius, key in the delta, 48 degrees, 48, delta. The curve is going to the right, so we press right, and we press Store. It stores points 3 and 4, and we're ready now to traverse to 5. So we press Traverse, press Azimuth, and we're going 90 degrees. Azimuth for a distance of 600 feet, and press Horizontal Distance, which brings us to this curve. We press Curve, give it the delta. Notice we can key in the delta first or the radius first. Then we give it the radius and press R. And this time our curve is going to the left, so we press left and press Store, and it stores the curve center, our radius point, and also the PT, which is 0.7. We're ready now to traverse one more time, and if we press Azimuth, the azimuth is 15 degrees. Press Enter for a distance of 500 feet, horizontal distance, and now it has stored 0.8. We're occupying 8, we've stored 8, the next number is 9, so we have traversed through the curve, storing the points by coordinates. We're ready now to enter the control file information. We press Shift right, Construction 5, Next, and HCCL for horizontal control. key in 1 space, that's the beginning point number is 1, then the beginning station number 100, we don't put the plus in there, space, to give it the curve information, which is 234, 234. To give it curve information, we need the quotes. In order to get the quotes, we press Shift right minus. Shift right minus. Now we have the double quotes with the cursor flashing. And we key in the numbers 2 space 3 space 4. Then we press the R key, the cursor right key to get outside. We press the space key, and now we're ready to go on over here to the next curve, which is Shift right minus 5 space 6 space 7, cursor right, space 8, enter. And that completes the horizontal control, and it's finished. We can press draw if we wish to see what it looks like on the display. And so far, it's looking good. There we go. And we press on to get out of that, and then exit. Now we're ready to enter our vertical control if we wish. Or, if we just wish to stake by station and offset, we could leave it in just horizontal control and go out there and do some work. For example, we could set up here, shoot there and there as our control points, and any place we take a shot, it will tell us the station and offset before we enter the vertical control and template. Let's give you an example of how that works. We go back to construction 5, shift right construction 5. Now we're occupying 8, backsighting 7, but let's go down here and occupy point 2 and backsight 1. Now, show us how we can occupy some known point, backsight some known point, and stake based on station and offset with just the horizontal control in. And let me just press setup to show you that you don't have to be in construction 5. If you're occupying a point number, you don't have to be in construction 5. We can press 2, occupy, 1, back point. We're setting it 2 and backsighting 1. But to stake, we could stake 5, for example, by just pressing stake and 5, foresight. Except in the stake mode, notice we're getting northeast here. Let's press change and bearing azimuth angle right. Now let's press stake again. Now you see we know the angle right to turn and the distance to go when we're setting on 2, backsighting 1, and staking point 5. So we're setting here, backsighting here, staking here. We turn an angle of 218, 20, 12 for a distance of 985.55. But let's go back to construction and show you the same thing. Shift right construction 5, and now let's stake point 5. 5, shift left foresight point. It shows us that we're on the center line, no offset. Offset is 0. The foresight station number is 618.88. So we know the station of 0.5. The angle right and distance were just the way they were when we're staking. But in construction, it gives us station and offset information as well as angle and distance to turn. Now let's suppose that we're going to stake a station, a point based on station and offset. We key in the station number, let's say 600. 6 plus 00 would just be keyed in as 600. We press space, and the offset, let's say, is 12 feet to the left. We key in 12 and press this plus minus key, so we're at station 6 plus 00, an offset of minus 12, and we press the soft key under foresight. And it tells us the angle to turn and the distance to go, and it tells us the station we are staking and the offset. So that's way down here somewhere. Let's do another one. Let's stake 1250 space offset of 50 feet to the right and press foresight. We're offset 50 feet to the right. Okay, we can press set up, and we're setting at 0.2, backsighting 1, and this is a station number here. Let's try give it another. Let's go to shift right and construction 5 and press key in a station number, space, and an offset distance. Press foresight, and it gives us the station, the offset, the station number, the angle to turn, and the distance to go. Now, if you want to write that distance down on a piece of paper, 2:17:09:27, 6:13.64, 65 really. You send your rodman out, you turn your angle to the right of that amount and set your instrument on that angle, send your rodman out this distance along that line, and you take a reading by pressing shot. Now in this case we don't have an instrument chosen. If you'd had an instrument chosen, this information would have automatically come in from the instrument. In this case we're going to key it in. Distance is 613.65, space, zenith angle, we'll assume it's 90, space, horizontal angle is 217.0927, and we press enter with a space between each of those, and see, station, offset, tells you come and write. So we must have taken, that's a good rodman. He did it just right the first time. Now, if you decide that you'd like to save that point, you can press this key where it says COOR. Let's press that. It actually stored 0.9. There's the station, the offset, and it stored the coordinates of the point at 0.9. If we'd like to store cut sheet information, station and offset information, then we just press cut sheet, CUTS, and it'll update the cut sheet. Now, if we would like to take a shot at any angle and any distance out through there, let's say that we just pressed shot and keyed in some distance, like 600, space, some zenith angle, space, some angle right, say 220, press enter. Wherever you take a shot, it'll give you the correct station and the correct offset for that point that you're at. This go and right business here only will relate to the last point that you tried to take a foresight on. For example, now I'm going to press on to get out of that, and I'm going to press exit to get back to my regular Construction 5 menu. Whenever you key in a value, station and offset, and press foresight, and then you press shot, it will give you go or come, right or left in relation to this last point. But if all you're looking for is taking a reading and getting the station and offset, you just press shot and don't worry about entering this. Okay, so we've shown you how you can literally use the horizontal control and stake based on station and offset. A point doesn't need to be stored there in order to stake it. We only have a few points stored. We stored these 8 points, plus we just stored one more point of a point we shot, point 9. So that's real simple when you're dealing with horizontal control. And you can work, if you're not worried about elevations, with stations and offsets in horizontal control. Let me tell you another application of this. Let's suppose that you have just a boundary fence line and you're traversing around through here. You can literally know the offset from your boundary line by just traversing and storing points. It'll give you the offset and the distance you've come along the traverse. This can be a baseline, as you've seen in the other example, as well as a road center line. And this road center line can be comprised of tangents, simple curves, such as this, tangent, simple curve, tangent, or you can enter a spiral in this area if you have spirals rather than a simple curve. Now let's go to one more stage. Let's put in our vertical control. We'll press Shift right, Construction 5, next, and we'll see VCCO, vertical control. Hey, it remembered that our beginning station was 100, so that already is put in for us. It requires the beginning station, beginning elevation, and the percent, and PVC, PVT, are percent and station, all the way to the end of the project. And now let's go in our manual to where we find the vertical control, which is right here. And we'll enter it. Station is 100, elevation 500. So we key in 500, space, 3.5, space. Now we're ready for the vertical curve. Shift right, minus to get our double quotes. Then this time on vertical curve we give it station numbers rather than point numbers. 550 space 800 from station 550 to 8 plus 00. Notice we did not put the pluses between there. We press arrow right to get outside the quotes. Now if we wish, we could press Shift right, return, and we could see what we've put in plus what we're about to put in. 2%, but it's negative, so we press the plus minus key. Remember, don't press this minus key to change a number to negative. Use the plus minus. Space. Now we're ready for another vertical curve. Shift right, minus for our quotes. 10, 20 is the station of the PVC. Space. 12, plus dot dot, and we don't put the plus in for the station of the PVT. Then we cursor right this R key, space, and we go the last percentage. So it's going to go plus 4% throughout. So we're beginning at station 1 plus 0, 0, elevation 500, percent slope is 3.5, PVC, PVT, percent slope, PVC, PVT, percent slope. And that's the end of the project. It'll go 4% through the end of the project. So when we finish, we simply press enter. It says compiling horizontal data, done. We could draw that if we wish by pressing draw. In this case we won't. We'll just press exit and we'll put in a template. And our template is it tells us what to put in here. Station, percent distance, and dot 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 until we get to the shoulder. Then a ratio to 1, the distance, ratio to 1. So let's take a look at our template. Stop that. Okay, now we're going to the template. So we press shift right, construction 5, next, and we see template, TMPL. Press that, and we notice that it also gave us the station of the beginning of the project, and we're going to give the template, cross-sectional template at that station, and we want the station, percent, and distance. Here we have a minus 0.4%, so we key in 0.4, remember, plus minus, to get it minus, space, then we give it the distance, in this case 20 feet, space. Now we could give it as many percents and distances as we would like till we get to the shoulder. In this case we only have one, but we could have a dozen different slopes and distances till we get to the shoulder. Once we get to the shoulder, we have 3 bits of information to enter. The ditch slope, ditch distance from the shoulder horizontally to the ditch bottom, and the back slope. And at this point, instead of using percent, we use a ratio to 1, like 2 to 1, 3 to 1, 6 to 1. But a ratio of 2 to 1 is entered, just 2. We do not put the 1 there. That means it's 2 to 1. The 48 knows that ditches go down from the shoulder, and so we don't have to give it a sign of negative. We give it this distance, which is 10 feet, space, and the back slope. In this case we're at 2.5 to 1, so we key in 2.5. So we have station, percent distance, and if we had more we'd keep entering them, all with spaces between them. Then the ditch slope from the shoulder to the ditch bottom, the ditch distance, the horizontal distance from the shoulder to the ditch bottom, and the back slope, the slope from the ditch bottom on out. Now it's necessary to enter those 3 elements whether you're in a cut or in a fill. If you're in a fill area and your ground level is way down here, when you take a shot here, it will ignore that, and it will automatically project this line down through here, and it will project for your catch point here as if the ground is level when you take the first shot. So remember, it's important, critical, to put these 3 elements in. So after you get it all in, you simply press enter. Notice what happened here. It projected all the way to the end of the project, the same template. However, if we wish, we can use the cursor keys to move up and cursor right and delete left, and we can get rid of that station number and key in some new station number. Let's say that we're going to station 5 plus 00, and we're going to enter a new template, space, and let's say at this point our slope is going to change to a minus 2%, we'll say, and maybe even the width will change, but in this case we'll just change the slope from here to here. Now when we enter this, and by the way, once we've entered just one element here, we can't go in here and add more. If we wanted 2 elements further on, we would add 2 elements here, say go minus 4% for 10 feet, another minus 4% for 10 feet, if we're going to have a condition similar to that on down the road. So we have made a single change here. We can make really a number of changes. We could change their ditch slope or back slope or whatever. But in this case, we're just going to make that one change. Press enter. And for example, that might have been at the beginning of a super. And now we may want to give it the station and the new slopes and distances at the max super. And then we can give it another station and slopes and distances where the super starts back, and then back at the end of the super. But in this case, we're going to assume that it holds steady all the way to the end. Excuse me. Then we press enter. When we're finished, notice we see the exact same thing on the screen again. There's no point in keeping pressing enter because that'll just store the same thing. So what we do is press on to clear that, and enter this time will throw you to the left template, and it'll exactly give you a mirror image of the template on the left side that you've got on the right. Here again, you can edit that if it needs to be different. So we use the same in this case. Notice what happens. It jumps to also where we made a change at station 5 plus 00, and to let us mirror image that information. Then we can edit that if we wish, or press enter to keep it. Now this jumps all the way to the end. Let's go ahead and keep it steady all the way through by pressing enter. But once we pressed enter one time, there's no point in keeping to pressing enter, so we press on to clear the information. This time when we press enter, it will now this is at the end of the template. We already have it stored. This time when we press on and enter, exit the program. We could draw that if we'd like by pressing draw. We can draw any of the templates we'd like, any station number. In this case, we'll let it default on station 1, and 1 represents right, so we press enter, and it's going to draw the template of the cross section. Here you see it drawing it across from the center line toward the shoulder. Now we're coming down from the shoulder down to the ditch bottom, and then we go back up from the ditch bottom, and that's a visual picture of what it looks like. And I've never personally considered these values on here of any value to me. So it just gives you a visual picture. Does it look appropriate? Maybe. Press on to get out of that, exit to exit that. Now we're still in this screen here. We really want to go back to the first screen in Construction 5. We can either press Shift right Construction 5 or Shift left, and next we'll back up the soft key menu. So this is the beginning of Construction 5. One of the things we should notice is we'll always see a home Kogo and Highway 1 after we've pressed on. User should be on, but notice we don't see any numbers up here. When we're working with elevations, we should see a 3 up here. So if we press change and elevation, it says will store elevation. Now when we press on to clear that off, we see a 3 up there, meaning elevations are now turned on. If we go back to our horizontal control and set up Shift right Construction 5, we're set at 2, and now let's try staking some station. Let's give it station 10 plus 0.0 at an offset. We press space to separate the station from the offset. Offset of 25 feet to the left. And we press foresight. So that gives us the offset, the elevation, and the delta elevation. Now notice our point that we're occupying was assuming it was 0 since we didn't give it an elevation for that point. It gave us the angle to turn, the distance to go. We're at station 10 plus 0.0, and so that gave us a certain amount of information there. But let's now show you how we'll actually establish an elevation for this point. We press more or we can press next until we see benchmark BM. In other words, we shoot a benchmark. Now if our instrument had been chosen, it would have automatically brought these point angles and distances in and give us benchmark elevation. Let's say that it's 200 feet to the benchmark, 89 degrees zenith, and angle right. It doesn't matter what that is because it doesn't actually use that. Now we see reverse. We could flop the scope and shoot it again. Benchmark point. If we had a point stored as a benchmark point by number, we could give it that point number and press this soft key. In most cases, we'll just know the elevation. Let's assume it's 505 feet. Press elevation. The elevation at the gun now, the reference elevation is 501. And let's store that at 2. 2, store. It says override. We press enter to override it. Now we're at 2. Now let's press Shift right Construction 5 and shot and just take a reading. Let's say 25 feet out, zenith angle 89, and an angle right of 20 degrees. We'll just take an arbitrary shot. It gives us the station, the offset, the elevation. Now this goal or come value doesn't really mean anything. That's to the last point we tried to stake. Fill left doesn't mean anything. So we need to have a fill here of 14.48 at this spot that we arbitrarily took the shot. This is the grade elevation based on the template. This is the actual elevation. Let's suppose that we wanted to store station 11 plus 50 and an offset of 45.23. We're in construction 5, so we press next and next and next until we see STO. We press STO and it stores it by point number. Now in this case, the next number was set for 3, so we'll store it at 10. So it says point 10 stored. So it literally created coordinates for that station and that's offset position. If we want to see the coordinate values for that, we could press view and 10 and point recall. There are the coordinates and the grade elevation. Oh, how far it is from point 4 to point 10. We key in 4 space 10 and press point to point. Okay, if we press 10 and press, by the way, when we press 10 we see some other numbers in there. It's not a bad idea to go ahead and press on to get rid of everything, then key in 10 again. Press foresight. Now that's not going to do much, because when you just press 10 in foresight, it assumes your station number. Let's give it 10 shift left foresight, and it uses the point number that's stored. There's your offset, elevation, the station number 11 plus 50. So everything is there. Create a point on the line between 4 and 5. We're going to press setup, 4, occupy, traverse, we press 4 space 5, press azimuth, and let's move for 100 feet. 100 horizontal distance. Change in elevation, we'll ignore that by pressing enter. That stored that at 11. So we now have a point 100 feet from 4 at 5. Let's suppose that we're setting our instrument up at a random position here, and we're going to call that 12, but we don't have the coordinates yet. We're going to compute them. We have points 4 and 5. I'm sorry, 4 and 11. This is 11. So I'll show you how we do that. We press more and resect. The first point that we're going to take a reading on is 4. 4, enter. If we were shooting electronically, it automatically give the distance. In this case, let's assume it's 100 feet. The zenith angle is 90, and the angle right is 0. We zero our gun on 4. Now we press shot 2, and the number of the second shot is 11. 11, enter. Slope distance we'll say is 100 feet. The zenith angle is 89, and the angle right is 60. If you'll notice, it's 100 feet from here to here, 100 from here to here, and 100 from here to here. So that creates a known condition by which we can create 12. When you're in the field, you can literally set up and shoot any two known points and create a known point here. It gives us the north and east coordinate of the occupied point and the precision, 13,000. That's because we had a zenith angle to point 11 of 89 degrees. We key in 12 and press store. So now we're setting at point 12. I wonder what the offset is of 12. Station offset is of 12. Let's see if we can find that. Shift right, construction 5, 12, shift left, foresight. There's the offset. We're 86.6. That's logical, isn't it? Station number is 10 plus 68.89. So you can find the station and offset of any point you have. We are occupying 12. We're backsighting 4. Mark from 12. We're occupying 12, and so we press setup, next, benchmark, and that benchmark is 50 feet. The zenith angle is 89, and the angle right is 0. And the elevation of that benchmark is 515 feet, and we press EL question mark. Now we key in 12 and press store. And we override 12 by pressing enter. Then we now are going to take a shot. We're going to do some slope staking. Shift right, construction 5. We're setting at 12, which is fine. We take a reading, take a shot. We press shot. Slope distance, we'll say, is 20 feet. Space. Zenith angle, space, angle right, enter. Okay, so it says we need to go in 18.86 or up 7.75. So let's try that. Let's take another shot. This time we'll press shot on the left side. And the slope distance is 38. The zenith angle is 86, and the angle right is 20. We press enter. This time it knows the slope of the ground. It says slope distance out 3.38 or down 0.44. Let me illustrate to you what is really happening here. That we took a shot was way out here outside the shoulder, outside the catch point. Then the next place was inside the catch point. Let's suppose that the ground is going like this, and we took a shot here. Now the next time we took a shot here, and it says slope distance in 3.38. So it knows the slope of the ground by allowing us to press shot on this side first and shot on that side next. Now once we move in here 3.38, we should press exit and take a shot with the right side soft key, simply because we want it to not get confused. If we get too close in getting our slope distance computations, it'll get a little confused. So after you once take a shot on the right side, then a shot on the left side, then you go back to a shot on the right side, so that you'll be dealing with a level distance. So slope distance we'll say is 38. 5 feet, zenith angle 87, and an angle right of 20. And here we're coming in real close to the catch point. Once we get at a satisfactory position for a catch point, if we press catch, then it will actually compute the catch from that position and store cut sheet information relating to it. Notice we have reference point here. If we wish to move outside 10 feet with the reference point, we can press reference point and it'll assume 10 feet, or if we key in 8 and press reference point, it will tell us the angle to turn and the distance to go to get to a reference point that's 8 feet outside the catch point. We take a sample reading and it'll give us the appropriate information to get back to the catch point. Notice it says reference point offset is 8 feet. And let me give you, we'll key in 17 degrees 16 minutes, roughly 17 degrees for 27.5 feet. By pressing, let's see, shot, slope distance 27.5, zenith angle 87, space and $17.6. There's the station, the offset, the elevation, catch elevation. We need to fill 0.39 at 8 feet, 8.02 feet, to get to the catch point. So this gives you the information you need to find your catch point from the reference point. Now let's press next and break from the catch, breaks from the reference. If we press breaks from the reference, it'll give us all the information we need to get back all the way to the center line for the grader. In other words, if you need to write all the information on the stake to get back to the center line along the template, you've got it displayed right here. Here we have cut 8.29 at 29.73, cut this amount at this distance, cut this amount at this distance, and it's 10 feet between here and here and 20 feet between here and there, which is correct. 10 from here to here and 20 from there to there. So this gives you a little feel for it. You'll realize that this program is extremely powerful in that it gives you the information that's needed to be written on the stake.